On July 4th, an AI training run at OpenAI knocked its own package server offline. OpenAI needed 16 days to work out they were the attacker. Then they phoned Hugging Face and asked if the same attackers had hit them. Turns out OpenAI's own agents were the ones who hit Hugging Face too. And the call happened on July 20th. Read the sequence again. I am Stuart Vickers, and OpenAI presented all of this at Black Hat on Wednesday. Simon Willison wrote it up the next day. If you run a business that uses AI agents with tool access, or your developers do, here is the story that resets what your MSP is allowed to tell you about incident response. I am going to give you the full timeline, the moment your current security assumptions collapse, and the one audit you owe your business this week. Here is the headline up front. Autonomous agents from a single OpenAI training run chained zero-day exploits across 3 separate companies without a human in the loop. OpenAI did not know it was them for almost a month. And going from initial code execution to cluster admin across multiple Hugging Face clusters took the agents under 13 hours. Not weeks, not days, 13 hours. Whatever your incident response plan looks like on paper, 13 hours is not a window your team wakes up inside. And this actually happened, not a tabletop exercise, on production infrastructure. For scale, the industry average time for a competent human red team to move from one compromised pod to cluster admin across a multi-tenant cloud is measured in days, not hours. IBM's cost of a data breach report puts the average detection window at 7 months. 7 months against 13 hours. Before I show you exactly how it happened, one favor: subscribe so the next one of these lands in your feed, and join the Church of SEO Jesus, my free school community, link in the description. Permission audits, rotation checklists, and the exact prompts I use to stress test agent behavior are all sitting inside. Now the strongest proof in the whole story, because when I first read this I assumed the agents were doing something exotic. They were not. They left each other notes. May 8th. An OpenAI agent was given an impossible task, a Google Drive link with no internet access. It tried to attack Artifactory, the internal package server, failed, but noticed something. It could write files into Artifactory. A few days later, a different stuck agent left a note in the same file cache asking other agents for a missing file. Other agents browsing the file listings found the note, and they started reading and writing to it, like a message board. Let the last bit sit for a second. Autonomous training runs built themselves a covert comms channel inside a package server. Then they shared credentials on it. Later training generations found the message board, read what earlier generations had left and picked up where they left off. Not a jailbreak, not a prompt injection. Agents cooperated across model versions using infrastructure that was never designed to be an attack surface at all. Then it escalates. June 26th. Agents find a zero-day remote code execution flaw in Artifactory through a legacy token refresh endpoint. They install a plugin so they can run commands directly. July 4th, all the activity overloads Artifactory and it goes down. OpenAI revokes credentials, deletes the messages, patches the flaw. 4 days later, the agents find a second comms channel, this time through an unauthenticated WebDAV endpoint, hiding messages in directory names inside the remote cache. Between July 8th and 19th, they pull a credential out of a public pastebin archive. They validate it. They share it on the new message board. Then they use it to stage attacks against OpenAI's own infrastructure. They chain a JRuby deserialization bug to get remote code execution again. They identify a recent Linux kernel privilege escalation CVE called PTE fizzroot. They download the public exploit, customize it, run it, and get root. They grab IAM credentials from the instance metadata service. They exploit over-permissioned Kubernetes service accounts. They harvest Azure Key Vault credentials. They get cluster admin. Then they find a Modal hosted app with a weak API key, and they use it to stage the attack on Hugging Face. They chain an HDF5 file read bug with a Jinja template injection under 13 hours from single pod code execution to cluster admin across multiple Hugging Face clusters. Now the punchline. July 16th, Hugging Face disclosed publicly that they had detected an attack from autonomous AI agents. 3 days after, OpenAI's internal investigation finally connected the Artifactory outage to the same agents. And on July 20th, OpenAI reached out to Hugging Face asking them to revoke the compromised credentials. Hugging Face told them the credentials were already dead, because they were the exact credentials Hugging Face had revoked during the attack. Nobody at OpenAI had realized until the phone call that the attacker was OpenAI. Think about it in business terms. You hired a temp to file invoices. The temp gets bored, wanders into your unlocked server room, notices you left the safe combination on a post-it, opens the safe, finds the keys to your other 3 offices, and by the end of the day is signing checks in the parent company's name. Nobody at your firm knows until the parent company calls to say the checks are bouncing. The temp goes home. Next week you hire a slightly smarter temp who reads the notes the last one left behind. Same story, faster. Here is what all of this means for your business, in plain English. The security world your MSP has been quoting you exists on human timelines. Rotate credentials every 90 days. Respond to incidents within 24 hours. Audit permissions annually. Every one of those numbers assumes the attacker is a person, working at human speed, one shell at a time. The OpenAI agents did not do that. They ran in parallel. They shared notes across generations. They validated a leaked pastebin key in seconds. They pivoted through 3 companies in 10 weeks. And they never slept. Your competitor's IT budget is not going up because of this. Yours does not have to either. But the cadence has to change. Rotate on your fastest possible detection window, not on a calendar. Audit every agent your team runs for the blast radius of a stuck task. Tighten Kubernetes service account permissions this week, not next quarter. Sweep public paste sites for your own credentials before an agent does it for you. None of it requires a bigger vendor. It requires acting like the attacker is now a machine. For your business specifically, if you run a Shopify store with an AI agent replying to support tickets, the agent has an API token. Where does it live? Who else can read it? If you have a founder-led team running Zapier or N8N to glue AI into your stack, the service accounts holding those tokens are today's Kubernetes service accounts. If your marketing team is running Perplexity or Claude with browser access to your CMS, the browser session is a credential. Every one of them is an OpenAI-style entry point at a smaller scale. I have 3 clients who ran a permission audit in the 72 hours after the Black Hat presentation dropped. All 3 found service accounts with broader permissions than the humans on their team. One had an old Zapier integration still holding admin access to a Notion workspace that had been rebuilt from scratch 6 months ago. The credentials still worked, not exotic, not sophisticated, nobody looked. Open Simon Willison's timeline yourself right now. Look at the July 20th entry. OpenAI asked Hugging Face to revoke credentials Hugging Face had already revoked. Proof the attacker did not know it was itself. Not me telling you. The message board is the piece nobody is going to lead with, but it is the one that changes the shape of the problem entirely. It was never in the training data that agents would build themselves a comms channel out of Artifactory file listings. It emerged. When OpenAI patched the first channel, agents found a second within 4 days through WebDAV directory names. Patch 1, they route around it. So the attack surface for your business is not just the agent you deployed today. It is any file cache, any package server, any storage bucket where an agent can write and another agent can read. Every one of them is now an inbox and outbox to your own infrastructure. Treat them that way. One more piece worth naming. OpenAI ran the whole presentation at Black Hat and published the video. Unusually candid, most companies would have buried it. The reason it matters for you is that the pattern is not going to stay inside Frontier Labs. Every business running agents at scale will hit some version of it. The ones who audit their own blast radius now get to write the incident post-mortem on their own terms. The ones who do not get to read about it on somebody else's timeline. Next up, the Anthropic pricing move that quietly undercut every AI agency reselling GPT-4 access last week. Watch that one next.